In this video, I'd like to talk about extending geometric sequences. And remember that for these geometric sequences, you can think of these as multiplicative. So essentially, going from one term to the next, you're going to be multiplying by the same number. And we call that number that you'll multiply by the common ratio. And so a big part of these problems is to first find that common ratio and then use that to find the next terms in the sequence. So for us, let's be general right now. Let's just call this common ratio equal to A so that we can notice a pattern. And essentially, with that common ratio, we're going to be multiplying by that number A, whatever it is, each step. And so to get the next term, we'll multiply by A again. And so to find A, you can think that we took our first term, we multiplied it by that common ratio, and we got 20. So to find the common ratio, we can just solve this equation here, divide each side by 5, and you get 20 over 5, which in this case is 4. So our common ratio is equal to 4. Every step of the way, we are multiplying by 4. And you can see that be true for any two terms you choose. For instance, if instead we took 20 and multiplied it by that common ratio A, we would get 80. But you can see that if we solve this, divide each side by 20, you get 80 over 20, which would again simplify to 4. So a pattern we can notice is that we can choose any number in our sequence and divide it by the term before it, and whatever that quotient is, that is our common ratio. And it's true for any term we pick, you can always divide by the one before it because that common ratio never changes. We're, in this case, always multiplying by 4. So to get this next term here, we're going to take 80 and multiply it by 4. And 80 times by 4 would be 320. So with that in mind, we could, if we wanted to, go to the next one. You do 4 times 320, which would be 1,280, and this geometric sequence would go on forever. But let's look at some different problems now. And this one's an interesting one because we're going to be counting down. So it might be difficult to see this common ratio since in this case it's actually going to be a fraction. But we can apply that same logic we used in the previous problem. We could call it some letter. Let's call it B, just to be different. And we know that if we take 72 to get to that next term in our sequence, we're going to multiply it by that common ratio. And we get 36. So to solve this equation, we're going to divide everything by 72. So 36 divided by 72. And now we just simplify this fraction, but you can notice that 36 is halfway to 72. So our common ratio in this case is simply 1/2. Or another way to think about it is that going from one term to the next, we are dividing by 2. And you can see that continues because 36 divided by 2 would be 18. Or 36 times 1/2 would be 18. And we didn't have to choose these two numbers. We can choose any two numbers we want. Remember, you can always take one number and divide it by the number before to find that common ratio. So we could have done 18 divided by 36 to find our common ratio of 1/2, which we already found from looking at 72 and 36. So to find that next term, let's just multiply by 1/2, and 18 times 1/2 is 9. And if we wanted, we could extend it further. 9 times 1/2 would be 4.5, or 9/2. 9/2 times 1/2 would be 9/4, or 2.25. And it will get smaller and smaller as we go since we're multiplying by a fraction this time. So let's look at two more examples. So this one's a little bit more straightforward. And our common ratio here, let's just pick any two terms here. We'll take one and divide it by the one before it. So let's do 18 and 6. We can take 18, we pick one term, and then you always divide it by the one before it to find that common ratio. And 18 divided by 6 is 3. And you can confirm that by looking at the first term and the second term. Notice that you just multiply 3 by 2 to get to 6. And we just found 6 times 3 is 18. And so to get that missing term, we're going to take 18 and multiply it by 3. And of course, 18 times 3, 3 times 10 is 30, 3 times 8 is 24, 30 plus 24 is 54. If we want, we can keep going. 3 times 50 is 150, 3 times 4 is 12, add those together, and you get 162, and this will go on forever. So let's look at one final example here. And this one you can notice is again counting down. And we start with a fairly big number, so it might be a little bit intimidating at first, but we just need to find that common ratio. And it looks like since we're counting down that we should expect a fraction. So remember with the common ratio, just take any term and divide it by the one before. Now, if we want, we could use the first two terms, but those are both bigger numbers, so let's use the smaller numbers. Let's take 21 and divide it by 63. And we just need to simplify this fraction, but you can notice top and bottom are both divisible by 7. So 63 over 7, that's 9. 21 over 7 is 3. And 3/9 would simplify to 1/3. So it looks like we're multiplying from one term to the next by 1/3. And so we want to continue that pattern to find that next term. So we can take 21 and multiply it by 1/3, or essentially we're dividing by 3, since this is 21/3 when you multiply it out. And 21 divided by 3 is 7. So our missing term here in this sequence is 7. And if we want the next term, 7 times 1/3 is 7/3, or 2.3 repeating. And then the next one would be 7/9. And it would go on forever, getting smaller and smaller as you go from one term to the next. And in the next video, we're going to look at when we have negatives or when we have fractions. So these can get quite a bit harder. But if you follow this same logic by finding that common ratio, taking one term and dividing it by the one before it, then they're really just the next step in difficulty.